Can you see my screen as well? Well, we move on from where we left last time, and we were talking about this was slide 14. Yeah, so the assessment, and then the decision, what needs to be recorded, and then before you start to make a rigorous uh, um, repair regime. So these are several types of failure. I think that these ones are straightforward. You can see. So you need the definition. You need to know the definition or the description of the potential problem. And how does that look? Because you can see that before you start repair, you have to go on site to do site visits and do visual assessment. That is the first thing. I think this is what we are talking about. The first step was visual assessment. Yes, visual investigation. So then you need to know really what do you need to write down. Okay, and so these are the details of visual inspection. Verification of the accuracy of the original drawing. So there is presumably a drawing that is in place, and for this reason, this is ideally why we have to go through the approval process. For example, the counties supposedly they should keep a drawing. Okay, it's a nice idea, but I think corruption makes it difficult. For example, I think there's some structures you may not really trace their drawing, but ideally, because this is the idea of usually it's called a development plan or roadmap, so that the development of a city has to fit within that plan. And often the reason why now every development needs to be submit a drawing, you know the procedure of, and then that that a copy of the drawing should remain at the county or the authority, such that in the future if you need a copy of the drawing, that should be availed, usually maybe at a small fee. This is the same thing with, for example, the um, land records. Also should be a map and the delineation or the property line. You understand? Identification of major alterations not shown in original construction documents. So the if there is some alteration that was, for example, the building was modified, that should also be kept. Should be, because anything actually any modification needs to be approved by the authority, like in this case the city county government. So in Nairobi, the county city, what is it? City county city, is it the city, the county of Nairobi? There's a department. Was in Gishu. Which county are you in? Kericho, is it? Kericho is a county in Nairobi. Okay. Kiambu and so on. Then identification of visible structural damage such as concrete cracking or spalling, and observations on quality of construction. Identification of potential non-structural falling hazards, including ceilings, partitions, curtain walls, parapet, fixtures, and other non-structural building elements. Observations on the condition of soil and foundation, documentation of the existing condition with photographs, key locations, etc. Details about any deviations observed at the site from original drawing. Um, so there is what was approved, okay, and then, for example, damage has occurred, or as the structure has some problem. The alterations on the structure could be partially explained. There is a possibility that the deviations are the source of the problem you wrote. So um, that's why you should be keen to compare the structure as on site with the drawings. Okay. So, and then if there is deviation, that should be the something that you focus on. So based on the data collected on this about the details of the building and visual observation of damage, distress in different structural components, and other system structural engineer experts have to categorize the type and severity of damage and make judgments about further course action. Rapid assessment of safety of the building becomes necessary after the occurrence of natural disasters like cyclones, earthquakes, to take decisions about possible evacuation of unsafe buildings to save lives. So, if uh, acts of God in your study of FIDIC, in one of the, is it management, isn't it? You talked about force majeure, is it? Yes. So such things, earthquakes and so on, when they happen, then some key structures need to be assessed, see whether they are safe or whether people can be advised to evacuate. Observation of settlement or differential settlement of buildings. The following causes are observed for granular liquefaction. Liquefaction, we've said that I think I taught you soil mechanics, so you are not lucky because I remember. You still remember what liquefaction is? Yes, soil. Actually, from the word, soil behaves like a liquid momentarily. So that's for the layman. As an engineer, you need to understand the technical meaning. Um, and I said that the soil has soil particles or the soil skeleton, but also often has water. So liquefaction is a problem when soil is saturated or saturated soil. So momentarily, because of the increase the loading due to earthquake and so on, the excess pore water pressure increases beyond. So this exceeds because you see weight of water particles, the water. But now, due to liquefaction, the pore pressure suddenly increases and overcomes the self weight of the soil. In this case, now soil behaves like of the gamma sat. So usually to assess the risks of the risks of liquefaction, or the factor of safety against liquefaction. Usually, the factor of safety against liquefaction is usually gamma sat minus gamma water over gamma water. So this value has to be at least greater than 1, so that the risk of liquefaction is not there. You understand? And I remember what I said before. So usually the submerged unit weight is the key. Submerged unit weight is gamma sat minus gamma water. And I said this is why if you stay, you said you come from where? From Busia. Butere. Is it sandy? So you are not like, you may not see this, but maybe in the fields. Where you stay in Londian, is it sandy? Okay, so maybe this phenomena you may observe elsewhere. Immediately after rain, especially in sandy, you see sandy soil, you'll see soil particles being lifted up in a manner, and it's called, in other words, it's called sand boiling. Just like the boiling action, if you boil water, you see the way water waves uh, come on top, and that convection or current. That is the way these sand particles will be carried out. And if you look at it, it looks like boiling. And in small scale, it would be called sand boiling, but in massive scale, caused by earthquake, called liquefaction. Now, this is common in loose sand, loose saturated sand, but also common in it can also happen in soft clay. Yeah. Then landsliding under monsoon rains or earthquake. So a loss of shear strength will cause sliding. Um, so again, the you can see that the increase in the earthquakes, what earthquakes does is kind of a shear load on the soil. So it will increase the excess pore water pressure. That momentary increase makes the soil lose shear strength. So everything is stable because the shear strength of the soil is greater than the applied shear. So the buildings, everything, the tunnel, whatever if whatever piles and so on, they are stable on the soil because the load applied is less than the shear strength that the soil can provide. Okay, but if the load applied exceeds the shear strength, then that is why you see a lot of instability. So liquefaction is one result or one effect of such. So the additional earthquake load makes the shear applied to the soil exceed the shear strength, and therefore you see that kind of instability in form of liquefaction. Again, sometimes because of excess rains, and could also be because of earthquake, the excess for water pressure in increases beyond the self weight of the soil. That in causes instability, and you see things like landslides and so on. So all this instability, the point is that the shear strength, the shear or the shear load or the load on the soil exceeds the shear strength of the soil. So all these things, liquefaction, slides, and so on, are a cause of, and in any form of failure, you can see on the soil, is because the load is more, the shear load is more than the shear strength of the soil. And this is the reason why we spend a lot of time trying to calculate equilibrium. Okay, when you are designing, for example, a retaining wall, you have to do calculations against sliding, isn't it? Overturning moments and so on. And that's all you are trying to do to make sure that the load you're applying does not exceed the available shear strength. Okay. Surface fault rupture under the building, remote possibility again. So this is in a nutshell what you're saying. That surface fault or rupture is just because the loads are applied exceed the mobilized shear strength. So, but these are things you can avoid by proper design. So these are some records. I guess this is a problem with earthquake or differential settlement. You can see the photo. So this is very common. I told you of the story where a woman was asking me what caused um, what caused the crack in some building in Ukambani. You remember? Yeah. So the crack actually was like this, and this is if you see near the either windows or near the doors like this, those are often tension cracks due to differential settlements. Okay, and I'm sure you've seen this this is very common in brickwork. Okay, yeah. So this one you need to really, and it also shows that there was very poor um, um, foundation work. And you can see now the edges are in tension, the middle in compression, and the other end. Those will cause tension cracks. And to avoid this, how can you avoid this? Yeah, you are not wrong. Yeah, you. This is why you see the bricks, even brickwork or in blocks. After every 2 layers, you put the hoop iron, isn't it? Yes. But this is a problem of differential settlement. You need to work on your foundation more. The best solution here is to work on the foundation, isn't it? You can also put the reinforcement. You can also put the reinforcement, but the key problem here is because of foundation issue, differential settlement, so to speak. Then you do your detailed investigations. When construction drawings of building layout and structural details, including the specifications of materials used, foundation are not available, then the detailed investigations have to be conducted about the total structural system and about the detail type, location, severity of damage or distress in various members and the system. So also you need to note that the reason for all approvals of the drawings, isn't it? But the drawings, there have been no clear, because that's where now you get, for example, the bearing capacity, how you decide to design your foundation. Uh, the good news, was it Kiambu? I saw a letter, was it from Kiambu, insisting that all drawings now must be accompanied by geotechnical report, and this has not been the practice. So you can see, as much as I've said before, that you can go to the county authorities or the county governments to get your drawings, you still have this missing part of the geotechnical report, isn't it? So the dimension of structural elements in the existing building have to be measured and noted. So you need to check for example, the beam has to be 400 millimeter in depth and so on. You measure and you check whether that is the same thing for the okay. So you need to confirm the dimensions. You can hear me, yes? Properties of structural materials, i.e., concrete, steel reinforcement, and masonry used in construction. Structural members is necessary and found non-static state in the field and carrying out restrictions on samples collected. So you, I already talked to you about Smith hammer, for example, and there are several other techniques we mentioned in the previous lesson. Okay, so those can be used to verify the targeted strength. Now, what I need to caution you is about brickwork, brick or masonry, because the strength of masonry work is important as the mortar. You worked on or you are aware how masonry design is achieved, isn't it? Design of masonry. So there is class 1, class 2, class 3 mortar. Is it there? Class 4? I'm not sure. Class 4, do we have class 4? Class 1, 2, 3. So the strength, the actual strength or the overall strength of, for example, masonry work is based on the mortar categorization, isn't it? Is like the type of mortar is a key consideration. All right. Yeah. So the overall strength, and of course, the specification is, I think, BS 5268, isn't it? But of course, now we should remove to the Euro code. Um, uh, so the equivalent Euro code, I can't remember which one. Euro code what? 2? I don't know. I'm not sure. Details of soil profile and its characterization have to be obtained by collecting data or by conducting necessary geotechnical investigations. The above state details are necessary when evaluating the safety of the belt to include or recommend finstoning mesh. So again, when doing research, you also need to know the strength. For example, length of the soil. For example, you need to enhance the foundation, parameters. You need to redesign the foundation. You need to reinforce it. You need to have an idea of the strength. Okay. Test for assessment of quality of reinforced concrete. Identify weak zones in structure. Detailed assessment in situ quality. In situ quality um, of materials has to be done for finding different properties of concrete. Various tests are shown to be conducted by the properties required selection or test to be done. So you can collect cores. So this is a destructive test. You collect cores just like you can collect what is undisturbed samples for soil. You can do pull out tests, all right. We can do pull off tests. We can do break off tests. So I'm going to demonstrate one. So the instance you put. I'm going to give you for example, an example. If you have what now? Okay, if you want to test, for example, uh, the C and phi parameters for example, steel and concrete. Okay, so what you do is have concrete, the first block of concrete, then you put steel in between, So just like the direct shear box test, you have one value of sigma 1 confinement, then you pull out as you measure the value you find, isn't it? So this is like a pull out test. So for different values of sigma, you find the different values of tau, you plot, and you have a nice straight line where this is the phi interface and this is the C interface. You have seen something like this, isn't it? Is it?
No.
No, this is direct shear box test, isn't it? The direct
shear box. Yeah,
yes,
that one I'm seeing.
Yes. So that's why I'm saying if you want to find the because you remember in soil you are told if phi for example is 32, then you are told if you are designing you take D for example to be 2/3 of phi, isn't it?
Yes.
So instead of assuming this, you can do that experiment using those two things, and the value you get here now would be the delta. You understand?
Yes.
So this is like the pull out test. So that's the pull out test, okay?
Yeah.
Now pull off. pull off is the same thing. The same thing. So if you take, for example, one block of concrete, then you hold one part, isn't it?
Yeah.
And then you try to break it apart, pull apart the other part. So that's like tensile test, eh?
Yeah.
Of course, it will snap here, and then when you're pulling apart, you see how much that load is, isn't it? So that way you test the tensile strength,
Yes.
isn't it? So for the
Yeah.
pull out strength, you talk about the frictional parameters like the C, the phi. All right. Then
Yes.
break off is just taking the material without confinement, and then you try to break it, and then you see how much that load is. Okay.
Yeah.
So you have an idea of pull out, pull off, and break off test, isn't it? And
Yes.
if you have a question, pause. You can ask me to clarify. And then the internal fracture, if there are any internal fracture mechanism. So these ones fractures, these ones you can use, for example, the infrared thermography, the special cameras you can check if there's any form of fracturing. Okay. You can use the wave methods where you produce you make, how can I say, you produce a pulse from one end and then measure the time it takes for the, the wave to reach the receiver, and then you compare because you know the speed in for example, in concrete the speed of sound is about between 3.5 to 3.5 to 4.5 kilometers per second, if I'm not wrong. Per second, if I'm not wrong. Now you know that, for example, then you compare you. So now you can measure and then compare with the standard we know that we know. So if it is 50% or if it is that range, then you know it is intact. If it is less, then you know that there is some cracks. You understand?
Yes.
Then this escort is enhanced structural. Is it structural? Enhanced structural something. It's nothing. It's just the. Wait. I want to make sure I remember it correctly. Enhanced structural concrete optimization testing. So this is nothing other than when you are doing the construction, there's rigorous testing, isn't it?
Yes.
Approvals and so on. So that's what we are saying during the construction stage. So you make sure that there is the strength as built, the strength of the material uh, is what is expected. Okay, and here you can enlist
Yeah.
the actual test. So whenever you are batching and producing your concrete, you take as much as you use the the constituted concrete, you take samples, you create samples for actual test in the lab, isn't it?
Yes.
And then on top of this, you can also use um, non-destructive tests. I told you of the distant destructive test. So non-destructive test to confirm that we at the strength development is conforming to what was required. So, for example, if it is class 25, so you need to know your theory well also, because if, for example, it's class 25 and you have been asked to do the what to do your test after 10 days. What is the range that you expect for class 25?
It should be about I don't know, 20. Just a minute. Around.
Your client. Concrete should have developed at least 67% of the strength in 7 days, isn't it?
I'm not sure. I'm not sure about that.
Yes, that is it. That is, should have at least, okay, we say 70, but the actual figure should be about 67. So that for class 25, 67% should be maybe 16 point, about 16, 17 there.
Yes.
So when you are doing your test, you check, for example, that the strength is around 16, 17. If it is below that, then you can advise them that the strength development is not okay. But I still have to caution you, because the these are indirect tests. For example, they are affected by the smoothness of the surface. They are affected by, for example, the day I went to do my test, there was some they had keyword in the morning. So when the surface is so when you remove the formwork, there's a lot of honeycombing. Okay, so that will affect your result. So you may get some very low value, and then you again the client will be alarmed. Okay, so I told you of, for example, how you take the test. You do about 16, and then you take for consistency. All right, of course, having made sure, are you there?
Yeah.
Of course, having made sure that the you, for example, tried your best to make sure the surface is smooth. Okay, as smooth as is possible. Sometimes that would be very difficult if the workmanship is not very good. And then you try that you get rid of as much water. Just how can I say? It's like a knee-jerk reaction. Okay, then maturity, you can do chemical or electrical test. Temperature match skewering. These are electrical. So you remember what I told you, that because the exothermic hydration process of concrete is an exothermic reaction that will cause
Yeah.
differences in temperature. So you can do that. You can check that test. Then maturity of concrete. We'll talk about that in detail. Penetration resistance, for example, penetration resistance to water, or penetration resistance to things like carbon dioxide. All right. Penetration resistance, for example, to iron. Then surface hardness. This one, Smith hammer. Do that. Ultrasonic pulse velocity. This is electronic radiography. So this radiography, all these things are X-ray based. Okay? Neutron absorption, radioactive, all those things are said that. Relative humidity, chemical, electronic permeability, petrography. So this one, petrography, is like taking a slide and then looking at under a microscope. Okay.
Yeah.
Sulfate content, expansion, air content. These are microscopic uh, in nature. Cement type and content. If you want to confirm the cement content, you can do. So these ones can be also seen in the petrography. You can see literally, if you cut a very thin slice and put it under microscope, you should be able to identify, for example, the fine aggregate, coarse aggregate, and be able to see the cement paste, isn't it?
Yes.
And then abrasion resistance, so those are mechanical tests. Can take samples and try to see, test the abrasion, and I'm sure you have done abrasion resistance test especially for aggregates, isn't it?
Abrasion resistance test. There is
Abrasion resistance. You take some aggregates, for example, put them in some there is a container, and then it goes through certain cycles, and you knew the original sizes, and then you try to pass them through the that sieve again to
yes,
see how
yes,
much.
yes,
You remember that?
yes, yes.
Yeah, that's abrasion resistance test. You can find more details later after this class. Corrosion of embedded steel. So half cell potential. So this one you check the, literally the concentration of ions. So you can measure the potential. You'll see, for example, voltage and so on, and this will cause, if there are ions accumulated, you will see there will be some potential, some voltage. You'll be able to see that. Resistivity, okay. Cover depth. This can be done with the electromagnetic means. There is a ferro detector you can easily buy. I don't know how cheap or expensive it is. That uses electromagnetic means, so you can somehow know the depth indirectly of the how far your how deep, or what is the cover of reinforcement. Okay. Then carbonation depth. These are chemical microscopic. How much carbonation has a paint? Chloride concentration. So those are chemical. So you can take some swab, like I've said, take to the laboratory, and you test for chlorides. Like you test for chlorides, like the solubility test. You remember solubility test? What is the test for chloride? Okay, anyway,
Uh,
if you can remember, or sulfate, so to speak. Then test for concrete strength is the most important parameter to assess safety of the structure against loading. Because of lack of construction supervision, concrete in the existing structure has very low strength. It's possible if there is poor supervision, the concrete may have low strength. Such locations are to be identified, and suitable remedial measures should be taken. Testing methods. Testing methods for concrete strength vary from indirect surface hardness to direct testing of concrete by removing ores. And destructive tests are based on indirect measurement of. So again, I need to caution you of non-directive, because you see, you are inferring indirectly. It's not a direct measurement, so it's not advisable to use non-directive, non-destructive tests independently of actual tests. For example, the strength cube crushing. Okay, because
yeah.
we use physics or indirect means to infer, for example, the strength. Now, such tests may have ambiguity of which can only be disambiguated by the actual physical test in the laboratory. I don't know what comes to mind. For example, is that the the pulse wave velocity uh, the pulse wave velocity, or the velocity of a P wave in water is about 1,500 meters per second. Okay. Now this is the same for example, sand. Sand, um, for the P wave velocity, for example, in things like clay are below 1,000 meters per second. Okay. Now, the pulse wave velocity, for example, in what is it, sandstone, is also around 1,500. Okay.
Yes.
So now, and the 1500 sandstone is relatively has good shear strength. So now, if you are relying on the p wave velocity to infer what kind of material you are dealing with, if, for example, if you find that velocity is about 1,500, you can see you will be in trouble, because you can either conclude that is sandstone, isn't it?
Yes.
Or some, it's not a good rock, but at least rock, some form of rock. Or, so you can either assume that or it is water. Okay.
Yes.
The only way to confirm that, if you took a sample, you could see evidence of water. Okay.
Yeah.
So this is why it's risky to make, and also you can see what I was saying before. For excuse me, for example, when you are telling me that the strength of at 10 days should be 6 Newton, isn't it?
Yes.
Now, if you did the test and you did not do it correctly, there is honeycombing and so on, and you find a very low strength, and you did not find another means to confirm this, then you would tell your client to actually demolish his structure, isn't it?
Yes.
That the you know, so you need to be very careful, okay, so that you become very objective. The result you give is free of any ambiguity, okay,
Yeah.
and most importantly, at the end of the day, your result is objective. So because we use indirect, the point is we use indirect means. So for surface hardness, rebound of an impact from the surface is measured. I have said that. So this is the rebound hammer test. So this is I don't know, condition attest. So this is some kind of NDT. The bottom corner. This is a rebound hammer. You can see my cursor.
Yes.
This is some kind of pulse wave, and then this may be ferro detector or something. Okay, so results of condition best. So visual observations, polling, and so on. And you can see we leave the criteria open because there is no procedure for visual inspection. It's you as the expert to know what to check for, what your suspicions are, and what are the evidence. Okay.
Yeah.
So corrosion damages, for example, to reinforce concrete structures, less damage at coated portions. So this is just like a table. You can feel probably you expect less damage. Okay, in comparison to
Yes.
the non-coated. Then rebound hammer test concrete in existing structure, design strength. So the rebound, the strength deduced from the rebound hammer test should be consistent with, for example, the design strength, isn't it?
Yeah.
Then of course you need to be on the lookout for strength portions with strength with low strength, isn't it?
Yes.
Should worry you. Then half cells will measure the negativity or positivity of concrete. So ranges are available. So you can see, the point is, if you can see some potential, it means there are concentration of iron somewhere, isn't it? And we are in this
Yeah.
case we are talking about negativity because the sulfate ions are negatively charged, the chloride ions are negatively charged, isn't it?
Yes.
And then you can see the range of the voltage. So if you can see some potential, then there's a probability of corrosion. So the caveat here is, for example, more value less than 350 millivoltage. That is the probability, there is a probability of corrosion. Okay.
Yes.
So millivoltage, that's the least cells. This one at least can power a calculator. Is it? What is the power of these small calculators? Should be able to successfully power this calculator. Is it? I
I'm not
guess.
sure.
I guess some small, or at least your watch, the watch, the hand wrist watches maybe. So electrical resistivity. This is how you measure the resistance, and of course the corrosion will make it less conductive. Okay. So
Yeah.
higher resistance will suggest that it's corrosion. So you should also be able to know the resistance of fresh or proper steel. Okay.
Yes.
Yeah. So if the resistance is quite high, then probably the corrosion. If it is less than 5, then uh, if it is greater than 20, then no corrosion. If it is less, no, sorry. So it appears that corrosion is reducing reducing the conductivity, isn't it? So if it's greater than 20, no corrosion. If it is less than 5, then it means there is severe corrosion. Of
Yeah.
course, you
Yes.
compare these values to the standards. Okay. So sorry, I think I miss
Yeah.
misspoke before. I said that corrosion worsens. Is it worsens the conduct? Eh? Okay, corrosion reduces the K, or the resistivity, electrical resistivity. In short, then carbonation. So only for other. So this carbonation is the attack by or deposit of carbon. Okay. So
Yes.
luckily, this is just a surface problem. So if you provide enough cover, probably you can uh, control this problem. So if connection reaches the rebar, then the rebar corrosion will be initiated. So the way to solve this, you can put enough cover, but this can only protect the rebar. For concrete, you have no issue. The only thing you can do is protect the surface to prevent this carbonation to penetrate inside the other layers. Okay, so you protect the
Yeah.
surface. But the other thing also, you should note that carbonation will affect the also the result of the rebound hammer, the hardness. Okay, so
Yes.
when you do this test, you should put uh, at the back of your mind the effects of carbonation, surface roughness. I've spoken to that, whether there is water or not. So the result may need to be corrected for these things. Okay, whether the surface with or not. Chloride content, measure percentage of chloride relative with weight. So less than 15%, less than 0.15%. If greater than that, it will be major cause of cathodic protection, the best option. So I told you the cathodic protection we applied in Mombasa, applying conclusive zar. Okay.
Yeah.
Yeah. Okay. Or any. This is one of the methods of cathodic protection. Or you can apply any. You can apply any appropriate means. It says are followed at every stage of construction to prevent structural damage and failure of structure. For good quality and durable construction of a structure, the following construction practices and techniques be followed. So this is just a good suggestion, and this is what has have been codified. This is the reason why we need approval. You come to an engineer to stamp for you, and then you take to the city to approve, just to make sure there is good practice. Okay. Now it is even required. The NCA are trying that if I stamp your drawing, they will send me an email to confirm